Implications for PBN, LNAV VNAV. The estimated horizontal and vertical position is compared against the defined path created by the navigation computer. The waypoints defining the path are normally extracted from the navigation database. Lateral and vertical guidance from the estimated position onto the defined path is called LNAV, VNAV respectively. Positioning accuracy. Position estimation accuracy is related to the type of navigation sensor used. Each sensor has its own error value, called the navigation sensor error. It is also linked to the dilution of precision. Dilution of precision is dependent upon the relative angle the signals subtend at the aircraft, angle of cut, and is used by the navigation computer to calculate the level of uncertainty in position estimation. Implications for PBN. Continued positioning accuracy. Some sensors are better suited to PBN operations than others. NDB is not considered in PBN as it is not accurate enough for position estimation. VOR, at long range, is the least accurate of the ground-based nav aids used in PBN. It is too inaccurate for the more demanding lateral track accuracy requirements, DME. Providing there are sufficient stations with appropriate geometry, supports most navigation applications up to a simple approach. The accuracy of a DME position estimation is too poor when the subtended angles, similar to DOP, of the signals from a pair of stations are less than 30 degrees and more than 150 degrees. GNSS, GPS and possibly other constellations, has the least error. With augmentation, integrity checking, provides a navigation solution for every navigation application. The aircraft manufacturers and aircraft operators decide which sensors are fitted to the aircraft.
The accuracy of a position estimate is influenced by the geometry, the range from the stations, and, for GNSS, the elevation of the signal. In this example, the aircraft is using DMEs to estimate its position. Clearly, DME position estimation will only be available when the aircraft is within the coverage of both DME stations at the same time. As we saw in the previous section, DME ranges may only be used when the angle of the two signals subtends between 30 and 150 degrees at the aircraft. When two range circles overlap, each with their own level of uncertainty of the exact range, the shape of the area where the position estimation could be is influenced by the angle of cut of those signals. The most precise position estimation that is possible is when the angle subtended at the aircraft is at 90 degrees. Each station has a difference between the estimated and the true range. As the angle changes, so does the level of precision in the position estimation. This is known as dilution of precision, or DOP. In the aircraft's current position, the subtended angle from the two DME stations is 29 degrees. Consequently, the position estimation is not good enough to be used. Once the angle of cut reaches 30 degrees, the two DMEs may be used for the position estimation. As the aircraft continues further, the angle of cut eventually passes 150 degrees, at which point the DOP is no longer acceptable and the system will have to switch at least one of the DMEs to maintain a valid position solution.
On-board autonomous navigation capability, although not a navigation sensor, position information can be provided by an inertial reference system, IRS. Inertial reference systems, IRS. This positional information is derived autonomously, without reference to any external systems, and can be used where no other position information is available. An IRS can provide short-term accurate information that can be used with ground or space-based navigation systems to enhance the position estimate. In addition, they can also be used to replace external sensors to cover short-term outages. The limits on their time of use are prescribed in the navigation specification. That is RNAV5, an inertial platform can be used for 2 hours with no updating, but for an RNP approach only for 40 seconds. An inertial navigation system, INS, is a standalone independent system. The inputs are fed from the inertial reference unit and waypoints can be manually entered through the inertial navigation control display unit.